Look, if you work in tech right now, your feed is probably just flooded with extremely loud industry noise about AI agents completely replacing DevOps teams, right? You've seen the bold claims, fully autonomous systems running entire data centers, algorithms making these incredibly complex infrastructure choices, basically the end of the engineer as we know it. But today, we're going to look past all that hype and focus on the grounded reality. In this explainer, we are going to examine exactly what is actually working in production right now. So let's dive right in and separate the futuristic fiction from the highly practical facts. To cut through the noise, here's our roadmap for this explainer. We'll start with myth versus reality, then look at where agents actually shine. Third, we'll cover when agents become liabilities. Fourth, we'll map out a defensible architecture. And we'll wrap up with the new DevOps reality.
All right, Section 1. Myth versus reality and the junior engineer paradigm. Now, before we look at the data, we really need the right mental model.
The biggest mistake organizations make right now is viewing AI agents as these autonomous infrastructure overlords. Honestly, that's just a recipe for disaster. I absolutely love this quote from our source material because it instantly disarms all the panic. The realistic shift isn't DevOps engineers become obsolete. If you're an engineer watching this, hear this loud and clear. Your high-level role, your context, your judgment, they remain completely intact. Your job isn't going anywhere. The nature of your daily friction is just changing.
There's a massive difference between the dangerous myth of literally handing over the keys, where a fully autonomous AI runs wild with high-risk behavior, and the genuine, useful reality. The most successful teams out there aren't walking away from the controls. They're deploying agents to tackle the painfully repetitive, high-volume, well-documented tasks. They're using AI to clear out the grunt work. Which brings us to Section 2, where agents actually shine, those high-volume wins. Let's pick up the pace a bit here because speed and efficiency are exactly what agents bring to the table when we unleash them on those unglamorous tasks. I mean, the sheer amount of human time saved here is literally staggering. Let's take the dreaded 3 a.m. incident triage. Normally, when that pager goes off, an on-call engineer spends 10 bleary-eyed minutes just pulling recent deploys and checking dashboards to gather basic context. An AI agent does that instantly, summarizing exactly what changed in the last 2 hours so the human can decide what to do immediately. Or a 10-minute manual CI/CD log dig. That turns into a 30-second verification of a first draft diagnosis. And for infrastructure as code, an agent can catch an overly permissive IAM policy before a human reviewer even opens the diff. And the wins just keep rolling in across other areas. Agents are incredibly good at log and metrics pattern matching. They can grep through thousands of lines to surface the exact 3 lines that actually matter. They can execute known, pre-approved runbooks as long as there are strict human guardrails in place. And my personal favorite? Generating documentation and runbooks straight from the Slack threads where engineers just finished solving an incident. Let's be honest, nobody likes writing docs by hand, which is exactly why they never get written. Having an agent do it is just a massive quality of life upgrade.
All right, Section 3, when agents become liabilities and managing the blast radius. We actually need to slow down for a second here, because we're talking about production environments now, and the gravity of irreversible actions really can't be overstated.
Take a look at this number, 999. Here's the crucial point. An AI agent might execute a destructive or complex operation perfectly safely 999 times. But without a human gate in place, that 1,000th time will be catastrophic and completely unrecoverable. The failure mode of an AI agent isn't that it's usually wrong, it's that it is highly capable, right up until it suddenly hallucinates a flag, misreads a threshold, and irreversibly deletes your production state.
And honestly, this is exactly why certain tasks are just immense liabilities. Fully autonomous production changes are so dangerous because language models can be confidently wrong in ways a rushed human might not catch. Irreversible or destructive operations, like deleting resources or rotating broad credentials, those must never be fully automated. No way. And finally, long-horizon ambiguous incident response. Agents are terrible at deciding business trade-offs. They don't know your risk tolerance, your customer impact, or if it's better to hotfix versus rollback. They completely lack the business context that human engineers possess. Which brings us right back to our core mental model. Treat agent suggestions exactly like you would treat a junior engineer's first draft. Think about it. You would never let a day one junior engineer unilaterally scale infrastructure or drop a database without approval, right? You'd review their plan first. Well, you need to treat your AI agent with that exact same level of scrutiny.
Moving on to Section 4, defensible architecture and building the guardrails. If we want to safely onboard this junior engineer, how do we actually wire the whole thing up? Well, it starts with the principle of least privilege.
A really great example of this in action is the Model Context Protocol, or MCP. Instead of granting an AI agent raw shell access or some wide-open API token, which, let's face it, is terrifying, MCP exposes specific, narrowly scoped, and explicitly named actions. You give the agent an action literally called restart service or rollback deploy. Essentially, you're giving the agent broad read access so it can investigate, but incredibly strict, narrow write access.
So, when an action is taken, it has to follow a strict sequence. Step 1, the trigger occurs. Step 2, the agent matches the issue to a known, pre-approved runbook. Step 3, and guys, this one is non-negotiable, explicit human confirmation. A human must physically say, yes, proceed. Step 4 is the execution. And Step 5 is logging that entire event straight into your observability stack. Every single state change must be a known sequence. This completely blocks any open-ended, do-whatever-seems-right behavior from the AI.
To summarize this defensible architecture, you want broad read access, but extremely narrow write access, period. Any state changes absolutely require pre-approved matches or human gates. And crucially, all agent actions must be logged with their full context. What triggered it, what the agent decided, and what it actually did. By logging all of this in your observability stack, your postmortems can reconstruct the AI's reasoning exactly like you would reconstruct a human's reasoning. You keep that audit layer completely intact.
Finally, Section 5, the new DevOps reality and human judgment.
Now that we actually understand the guardrails, how does day-to-day life change? What you should really take away from this is the profound shift in where human energy is spent. The old focus was exhausting, right? Log splunking, tedious context gathering at 3 a.m., manually drafting runbooks. The new focus, enabled by carefully constrained AI agents, actually elevates the engineer. Your time shifts toward high-level judgment calls, safety verification, and deep root cause analysis. You remove the friction of simply finding the problem, which frees up your mental bandwidth to actually make the critical business decisions on how to solve it permanently.
So as we wrap up this explainer, I want to leave you with a final thought. Go look at your own automated approval layers. Look at the tools your teams are adopting right now and ask yourself, are you treating your AI like a junior engineer, or are you just handing it the keys to the data center? Because the teams getting hurt aren't the ones adopting agents, they're the ones adopting them without the guardrails. Keep your humans in the loop, lock down your write access, and let the agents handle the heavy lifting.